Hi, welcome back to the channel. In this video, we are going to discuss about the map interface in Java Collection Framework. Map is a part of a collection framework, but it itself is not a collection like list, queue or set because it doesn't extends the collection interface. Map has three different major implementations that gives us the three different types of maps. Now these three different types of maps are unordered map, ordered map and sorted map. So we will look at these three major implementations of the map that are used more frequently as well as are of the utmost importance. So let's start by the first implementation, that is hash map. Okay, so hash map, as the name suggests, is based on hash table. Now we have seen that the set implementation, especially the hash set, is also based on the hash table implementation, in which I have given an idea about that how it is implemented internally. So hash map is also internally uses hash table to store the values. Let's see how it is implemented or how this implementation look like. Now we take the reference variable of map interface and the object of type hash map. All hash map directly implements the map interface and has no new methods other than what is present in the map interface. Okay, so the method to insert the object or to insert the key value pair is map.put. Now currently we have taken the key as integer and value as also integer, but we can change the data type of key as well as value. We can have any one, but remember that the key has to be unique. If you try to insert a identical key or duplicate key, then the value will get updated in that case. So let's say 1 comma 4. Okay, let's say next is 5 comma 43. Let's say 10 comma 34, and let's take one more value, 45 comma 34 or maybe 90. Okay, so here if you try to print a map, it will give you in a bit different way. It will look like 1 equal to 4, 5 equal to 43, 10 equal to 34, 45 equal to 90. So first one is the key and second one is its value. Now this is a very simple looking how the map actually looks like with its key value pair, and you can see that the order in which we have inserted, though it is coincidentally showing this order. So let's put this up. Let's see if mostly it will not change the order. Okay, so now you can see that our insertion order, we have inserted 1 comma 4 first and 45 comma 90 as second, 5 comma 43 at third and 10 comma 34 at last, but the order in which it has been showing us is completely different. So it is an unordered map. Okay, now you might be wondering that it doesn't implement collection interface, then we cannot iterate it. No, we can iterate it, but to iterate the map we have to first get a collection view of the map. So we can get it. So how we can get it? So let's use a for each loop. So in for each loop, first we have to mention the type of variable. So the type of variable to refer to the object in the map is map.entry. Now map.entry is a special type of interface that provides us a collection view of the map. So we also have to specify the key value pair data type. So data type has to be the same as that of the map, and here we have to provide map.entry set. Now map.entry set, as the name specifies, gives you the set view of the map. Now set because it is a part of the collection, and or you can say it is a collection itself because it extends collection interface. So or now we can iterate the map. So how we will do it? It gives the map.entry interface gives us a method that is get key, and it also gives m.get value. So now we can, through this we can individually get key value pair. Now if I run this, now you can see that 1, 4, 5, 43, 10, 34, 45, 90. Okay, so individually we can get the key value like this. Okay, map. Now next implementation is linked hash map. Now linked hash map extends hash map, and it has its no new methods, but what it provides us is the ordered map. Means internally it uses linked list for the inserting of the elements, and therefore it provides the order. So in the order in which we insert into the map, that same order the map gives us. So let's implement this also. So let's take of this integer integer. Okay, so we take or just we take m linked hash map. Okay, it also has put. The thing is that these methods are same, so it's not anything different. Okay, now 4, 7 m dot put 10, 67 m dot put 0, 1. Okay, so we have inserted 4 things. Now if we print this linked hash map, okay, so you can get this. This is the linked hash map that we have got: 3, 6, 4, 11, 10, 67 and 0, 1 in the same order that we have inserted. Okay, and the same way we can iterate it. All the methods are same. Now let's see what are the some of the common methods. So map dot contains. Now contains has 2 important things. One is contains key and contains value. If you want to check for if a particular key is present or not, you have to write a key. So if I say does this contains, okay, I just write in the s out. Does this map contains 45? Suppose I want to know that this contain the key 45, so it is true. Now if you write 40, so it will give you the false. Okay, and similarly is for the value. You can search if you want that. Okay, if there is any value like 100 or 100. Okay, let's first say for 100. Wait, I didn't change. Contains value. No, there is no value of 100 for any key. Okay, if we look for 90, then we get true, because there we have one key associated with the value 90, right? Okay, now the map interface is extended by sorted map interface, and it is further extended by the navigable map interface, which is implemented by a tree map. Now tree map is gives us the sorted map basically. Okay, so next is tree map, and this tree map gives us the sorted map. Internally it implements a red black tree. Okay, So we should take the uh, interface navigable map of type this, and let's write tree map. Okay, right now the insertion is as similar as you can see. 5,70 tree map dot put 34,21 tree map dot put 0,12 and tree map dot put 86,43. Okay, now we have inserted these. We want to insert these three. So your next question is how these will be sorted, because we have key also as integer, we have values also as integer. So in tree map by default uses key as the sorting criteria. Okay, so it sorts by key. Also it's by default uses ascending order for sorting. Okay, it puts the inserts in the ascending order. So if you print this tree map, you will get, okay, you will get the map view that you first 0,12, then 5,70, then 34,21, and then 86,43. Now suppose you want to reverse, you want to do in a descending way. So in here in the constructor for the tree map, you just have to write comparator dot reverse order. That's all. Now if you print this, you will get in reverse order 86,43, 34,21, 5,70 and 0,12. Okay, so this is the implementation of the tree map. So various implementations are for their various use cases. Now we have still now seen the 4 different interfaces and 4 different data structures that are, or probably 5 different data structures which are there in collections framework. Right now in the next one we will see how these data structures, or how list, set and map, queue, stack, all are, how to iterate them. Now you may say that we have saw this iteration thing. Yeah, this is one way how we can iterate. There are multiple ways in which the collection or the map can be iterated. So we will see in the further videos, and then we will focus on some of the important questions, some of the interview questions, some of the data structure and algorithms questions, and we will go deep into the collection framework and on how it can help us in solving the questions very easily and in an efficient manner by managing our time and space complexity. Okay, stay tuned for the next video. Until then, bye bye.